Okay, so 5.6, finding rational zeros. And if I were to give you something like you see here, obviously a polynomial with degree 3, to find these zeros, my first thought would be to factor, and I see that I could potentially group this. And I'm going to take out an x squared, leaving me x plus 1. And I'm going to take out a 2, leaving me x plus 1. And I have a factor of x plus 1, and I have a factor of x squared plus 2. So that's factored, but I want to find the zeros, so I now want to solve. So I take the first and set it equal to 0, and I take the second and set it equal to 0. And remember that negative, when I take this square root right here, I'm going to get an I, and square root of 2 does not simplify. So, rational, irrational, imaginary. Rational means, don't forget, can be made into a fraction. So, this would be a rational zero, or a solution, or a root, whatever you want to call it. This would not be. So this particular polynomial has one rational root and two imaginary roots. Okay, so this is a lot of words and letters that will make a lot more sense in a minute. The rational zero theorem says that if a function of x, which equals a sub n times x to the n, plus a sub n minus 1 to x to the n minus 1, plus da-da-da-da-da, plus a sub 1 times x, plus a sub 0 has integer coefficients, then every rational zero of f has the following form. P over Q equals the factor of constant a sub 0 over the factor of leading coefficient a sub n. Okay, so what does that really mean? I just want you to picture that n is 5, okay? So this really, let's just say that n is 5. So it would change this to a sub 5 x to the 5th plus a sub x 5 minus 1, which would be 4 x to the 4th, plus a sub 3 x cubed plus dot dot dot, plus a sub 1 x to the 1 plus a sub 0. Okay, it's not a big deal. I'm going to explain it in a minute with real numbers. Okay, so what the rational zero theorem says, it finds the possible zeros, all of the possible zeros. Okay, so the first thing I need is I need a sub 0, and that's going to be negative 6. And I also need a sub n, which is the very first leading coefficient, which would be 1. So now I'm going to write all the factors of a sub 0 and put them over the factors of a sub n. Okay, so what does this look like? All right, so the factors of a sub 0. I can get 6 by multiplying positive 1 times negative 6. But I can also get it by multiplying negative 1 times positive 6. I can multiply positive 2 times negative 3, but I also could do negative 2 and positive 3. Those are all the factors of 6. 1, I can multiply 1 times 1 or negative 1 times negative 1. Okay, now I need to list all the possible combinations here. So I have positive 1 over positive 1. I have positive 1 over negative 1. Now I'm going to go to the negative 1. Negative 1 over positive 1, and negative 1 over negative 1. Now I'm going to move to 2. I can do positive 2 over positive 1 and negative 2 over negative 1, positive 1. I think you're realizing that I really don't need to write positive 1 over positive 1 and negative 1 over negative 1. I can do plus and minus 1 over plus and minus 1. Okay, so I'm now going to erase all of these. Oh, don't want to erase. Okay, so instead of doing it this way, I'm just going to say I can multiply plus and minus 1 over plus and minus 1. I can also do plus or minus 2 over plus or minus 1. I can also do plus or minus 3 over plus or minus 1. And I can also do plus or minus 6 over plus or minus 1. These are all of the possible rational zeros. Notice they're all ratios. Okay? All right, let's try number 2. Okay, I want you to fill in what a sub 0 is and what a sub n is. So a sub 0 is -4, that's the constant, and a sub n is 5. Okay, so this will be a little bit more interesting. So we're going to do the factors of a sub 0 over the factors of a sub n. So the factors of a sub 0, I can do plus or minus 1 times plus or minus 4. I can also do plus or minus 2 times plus or minus 2. But I now have plus or minus 1 times plus or minus 5. Okay, let's just make sure you understand that. To get -4, I can multiply positive 1 times -4 or -1 times positive 4. To get -4, I can also multiply positive 2 times -2 or -2 times positive 2. I'm just listing them all like this. To get positive 5, I can multiply positive 1 times positive 5 or -1 times -5. But now I need to come up with all the combinations. So the combinations will be all possible zeros. Remember, these are all just possible. We don't even know if they work. They're just possible. So I'm going to say, okay, I can divide plus or minus 1 by plus or minus 1, and I can divide plus or minus 1 by plus or minus 5. I can divide plus or minus 2 over plus or minus 1, and I can divide plus or minus 2 over plus or minus 5. I can divide plus or minus 4 over plus or minus 1, and I can do plus or minus 4 over plus or minus 5. Okay. That means that 1/5 could potentially be a rational zero. -2 could be a rational zero. -4 over 5 could be a rational zero. You see all the combinations that I could have in here. These are all possible rational zeros. Okay, so once we have the list of possible, to find the actual zeros, you test values from the list of possible zeros. That means you must synthetic divide until you get a remainder of 0. And this should be a small f, shouldn't it? Okay, so we're going to attempt to do this on this polynomial, cubic. Okay, it obviously, if I look at it and just in my head kind of visually group it, there's only an x squared here, I would get x minus 4. Here I could take out a 3, but I'm not going to get x minus 4. So my groups would not work, which means I cannot group this. So I'm going to list all possibles. So we're going to list all possibles, which means a sub 0, factors of a sub 0 over factors of a sub n. A sub 0 is going to be the 18. And a sub n is going to be a 1, leading coefficient. So the factors of 18 are plus and minus 1 times plus or minus 18, plus or minus 2 times plus or minus 9, plus or minus 3 times plus or minus 6. And I'm going to put that all over. I love it when the leading coefficient is 1 because then we just have plus or minus 1. Okay, so we're going to test. And if I started listing all of these, I would have 1 over 1, I'd have 1 over -1, I'd have 2 over 1, 2 over -1, 3 over 1, 3 over -1. So I'm going to start at the beginning of my list, and I'm going to synthetic divide, starting with my first one. I have a cube, I have a squared, I have an x, and I have a constant. I'm going to bring down the 1. I'm going to multiply here to here, put it here. I'm going to add, I'm going to multiply here to here, and I'm going to add, and I'm going to multiply here to here, and I'm going to add. Oops, you can see my mistake. This is a positive 18, so this should have been a positive 18, and when I add, I get 0, which means that 1 is a solution because the point 1, 0 is on the x-axis, so it is a solution. And remember, we always keep a placeholder. This is a cube, which means I brought this down to a squared. So I now have x squared minus 3x minus 18, and that will factor as x minus 6, x plus 3. So I get 6 and negative 3. So my three solutions are the original one that I divided by that gave me a 0, and then the positive 6 and the negative 3 that I get from my factors. Out of all of these possibles, I have 3. And we know it's 3 because of that. We know there are 3 total solutions because of that. We just don't know how many rationals. So let's try this one. This is a quartic. Leading coefficient is 9 and my constant is 12. So the first thing I'm going to do is I'm going to list all of my factors of my constant. So I get plus or minus 1 times 12, plus or minus 2 times 6, plus or minus 3 times 4. I just like them in numerical order. Okay, now over the leading coefficient, so I can do plus or minus 1 times 9 or plus or minus 3 times plus or minus 3. Those are all the possibilities. So I want you to think about this. I have 1 over negative 1. I have 1 over positive 1. I have 2 over positive 1 and 2 over negative 1. I have 3 over positive 1 and 3 over negative 1 and so on. But I also have 1 over 3 and 1 over negative 3. And I also have 2 over 3 and 2 over negative 3. I also have 1 over 9 and 1 over negative 9, and so forth on down. There are a ton of possibilities. So we're just going to start dividing. And this time I'm going to start with negative 1. I have a fourth, I have a cube, I have a squared, I have an x, and I have a 12. And I'm going to bring this 9 down, multiply, put it here, add, multiply, put it here, and add, multiply and put it here, and add, and I see if I multiply and put it here, I am not going to get a 0. So what do? I go all the way back to the beginning, and I try something else. So we're going to try positive 1 this time. Multiply and add. Multiply and add. Oops, sorry. 18. Multiply and add. Multiply and add. Whoo, yay! Positive 1 is a solution. Remember, placeholder, cube. Okay, at this point, I'm going to try to visualize in my head that I have 9x cubed plus 12x squared minus 18x minus 12. And I'm going to see if this will group. So I'm going to group right here and see if it will group. In the first group, I'll take out a 3x squared, leaving me 3x plus 4. And in the second group, I'll take out a 6, leaving me 3x minus 2. And those groups do not match, so I cannot group. So guess what I have to do now? I have to drill down another layer. So I have to go back to my list of possible rational zeros and pick one. And I'm going to go to negative 2. Of course you are, Mrs. Irwin, because you know that that's going to give you one and you don't have to do all the work that you're asking us to do. But that's life. Yay! Negative 2 is a solution. And now I've come from a fourth to a third to a squared. And what I have left is 9x squared minus 6x minus 6. And the beauty about that is it's a quadratic, and I can solve it however I want. So the first thing I'm going to do is factor out a 3. And see if that will factor. And I guess and check. Oh. I don't think that's going to factor. 2 times 1, that's going to give me 1. If I put 2 times 1 in the other way, that's going to give me 5. Okay, so that won't factor. So now what do? I ditch factoring. And I go to quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Notice I'm using the quadratic that's inside. Okay, I factored a 3 out of each of these. My solutions are going to still be the same. The 3 is just a vertical stretch. So when I solve this, I'm going to get x equals 2 plus or minus 6 root 7 all over 6. And I see that I can divide a 2 into each of these. So my final answer is going to be 1 plus or minus 3 root 7 over 3. So I have 4 total solutions. 1, 2, 3, 4. I'm going to write those correctly up here. So I'm going to do 1 plus root 3 over 3 and 1 minus root 3 over 3. I have 4 total solutions. Only 2 of them are rational. These 2 are rational. These are irrational because that square root of 3 is going to give me an irrational number. Okay, so you're going to need to pause and catch up to me here. Okay, make sure your points go through the same points. So this is by 3, this is by 1, it goes through -1, it goes up through 15, comes down between 1 and 2, hits 2, -1, and goes up between 2 and 3. Okay? So now what I want to do is I want to list all my possible zeros. So I know it's factors of the constant. I guess I didn't have to write them that far apart. Over factors of the leading coefficient. So I have 1 and -1. I have 3 and -3. I have 5 and -5. I have 15 and -15. But I also have 1/2 and -1/2, 3 halves and -3 halves, 5 halves and -5 halves, 15 halves and -15 halves. I also have 1/4 and -1/4, 3/4 and -3/4, and so on. Okay, well, some of these we can eliminate. Okay, I know I can eliminate anything that is bigger than 3. I can eliminate. So 15 over 2 I can eliminate, 15 over 4 I can eliminate, bigger than 2 I can eliminate, bigger than 2, or less than -1. So I can eliminate all of those. Okay, I can eliminate -3. I can eliminate +1. I can eliminate +3. Okay, see how I can just eliminate by looking at the graph? I see obviously that it goes through -1. Okay, but I can kind of take a guess, and let's see if it goes through 1.5 or 2.5. Okay, so let's just experiment with 1.5. So I'm going to synthetic divide with 3 over 2 into cube, square, x, and constant. If I bring down 4 and I multiply these two right here, I'm going to get 12. No, I'm going to get 6, sorry. And if I add that, I'm going to multiply those, I'm going to get negative 9. If I add those and I multiply, I'm going to get negative 15. So 3/2 is a 0. So that's the way that you can eliminate from your possible zeros. Last page, 2 seconds. I would like you to find all possible zeros of this cubic. And I would also like you to tell me the end behavior. This should be at the end of your notes, and if it isn't, you will not receive higher than a 50 on these notes. I would hate to see that happen since these were long. You guys have a great Thanksgiving, and I hope you had a fun game day with the sub.